All right, we are recording. Let's have a look at these questions. 83. So we have fx equals 2x squared minus 3x minus 5. And we have to find the degree. So the degree is 2, it's a quadratic. We have to find the zeros and the intercept. So I think the intercept on the y-axis, that's pretty easy. You just put x as 0, so you get minus 5. Now to find the roots or the zeros. So 2x squared minus 3x minus 5 equals 0. Can I factorize this? 2x here, x here, has to be 5 and 1, 5 and 1, minus and plus equals 0. Let's see, does that work? 2x squared minus 5, 2x. Yeah, that looks right. So x is 5 over 2, or x is minus 1. Is this function even or odd? I'll check in a moment. Well, I can tell it's neither from the zeros here, because what will happen is there'll be one here at 2.5, and then one here at minus 1, so it's not going to be symmetric. So it's neither, because f of minus x would be 2x squared plus 3x minus 5, which does not equal f of x or f of minus x. So sorry, minus f of x. So it's neither. And finally, the behavior, the end behavior. So when x goes to infinity, this function will rise to infinity, and when x heads to minus infinity, this function will also rise to infinity, because the 2x squared term dominates in the expression for large values of x. Let's just see if the answers match the back, since it's odd. 2 minus 5, 5 over 2 and minus 1. Both ends rise, neither. And degree, yeah. Okay. Yeah, so we're doing fine. Okay, let's have a look now at 84. So fx equals minus 3x squared plus 6x. So the degree is 2. The intercept, that's 0. Let's get the zeros now. Minus 3x squared plus 6x equals 0. Divide by minus 3. That's x squared minus 3x equals 0. Isn't it? Divide by minus 3. X squared. No, Stephen. That's a 2. So take out the x. You're left with x minus 2 equals 0. So that's 0 or 2. Is it even or odd? Let's find out. F of minus x would equal minus 3x squared minus 6x, which does not equal either f of x or minus f of x. So again, it's neither. And again, when x tends to infinity, this function will tend to minus infinity. And when x tends to minus infinity, this function will tend to, again, minus infinity. '84. Oh, 85. Fx equals a half x squared minus 1. So the degree is 2. The intercept is minus 1. And then a half x squared minus 1 equals 0. That means x is equal to plus or minus root 2. as the zeros. F of minus x, that would be a half x squared minus 1. So that's still f of x, so that makes it even. If it was minus f of x, it'd be odd. And then when x tends to infinity or minus infinity, f of x will also become infinite. So basically for large values of x, the function is increasing, just similar to the other ones as well. Answers are at the back, so we can confirm. 2 plus or minus root 2 minus 1, both ends rise, and it's even. Okay. Am I still recording? Yes, I am. Okay. 85. 86. Cubic now. Fx equals x cubed plus 3x squared minus x minus 3. The degree is 3 and the intercept is minus 3. Oh man, they are making me solve a cubic. That's just fine and dandy. X cubed plus 3x squared minus x minus 3. Well, I can spot x equals 1. So that's one of the zeros, or the roots as I call them. So we long divide to get the others. Okay. X cubed plus 3x squared minus x minus 3. I know 1 works because if I sub 1 in, I do get 0. So 1 definitely is a solution. X squared, x cubed minus x squared, 4x squared minus x, plus 4, 4x squared minus 4x, that's 3x minus 3, x plus 3, 3x minus 3. So I can definitely factorize that. That's x plus 3 and x minus plus 1. So that means x is 1 or plus or minus 1, or also minus 3. There's 3 possible zeros. Minus 1, 1, or minus 3. That doesn't matter. And then the end behavior, when x goes to infinity, this function, the cubic term, dominates, and that will go to infinity. And when x goes to minus infinity, the cubic term dominates, and that will go to minus infinity as well. It's cubed, the sign is preserved. And lastly, is it even, odd, or neither? It's going to be neither, because f of minus x is minus x cubed plus 3x squared plus x minus 3. So it's neither plus or minus f of x. Okay, 87. Much easier one. Fx equals 3x minus x cubed. Actually, I can check that cubic there just a second. Okay. All right. Degree, 3. Intercept, 0. Then 3x minus x cubed equals 0. Take out the x. I'm left with 3 minus x squared equals 0. So that means x is 0, root 3, or minus root 3. What else do I need now? The behavior at the end. So when x tends to infinity, fx will tend to minus infinity, and then when x tends to minus infinity, fx will tend to infinity. And let's see if it's even or odd. I think it's odd. Is f of minus x will equal minus 3x plus x cubed, which equals minus f of x, which makes it odd. And let's just confirm the answer since I have it here. 7, 3, 0, 0 plus or minus 3. Left end rises and right end falls, and it's odd. Okay, that's that batch done. You still recording? Sometimes this program crashes, so I'm making sure I'm not talking to myself. For the following exercises, use the graph of fx equals x squared to graph each transformation function g. Yeah, okay. I'll try and do this as neatly as I can. So let's start. I'll just go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. So the fx equals x squared. So that'd be 0, 1, 2, 4. So that's just regular old boring fx equals x squared. But then we want to graph, this is 88, gx equals x squared minus 1. So the effect of having the minus 1, it is basically fx minus 1 is the point. So that g graph will look like the f graph, but lowered by 1. So if you just drop everything 1 unit, that's what that g of x will look like. And if I just repeat it again for the other g of x, maybe I'll do that one in green. That's 89. So that g of x, that's x plus 3 squared plus 1. So that would be f of x plus 3 plus 1. And this one will move it up 1 unit. And this one is kind of initially counterintuitive. It moves it left 3 units. So I'll put it darker green. So it start off with the red f of x and move it up 1 unit. So that lower point goes up 1 unit. And then 3 units to the left. 1, 2, 3. So that minimum red gets up and across. And then this one here goes up and across 3 units as well. So that would be at minus 4. This one here will go up and across 3 units. So that would be at minus 2. And then this one here will go up and across 3 units. So that'd be at minus 5. And then this one here go up and across 3 units. That'll be at minus 1. So I should actually I'll do purpley. So there we go. That one's up and across to the left. If I look at the graph for 89, that matches up pretty nicely actually, except I didn't write in the y the x. So yeah, I'll try and make this a little bit neater. So that's equal to f of x minus 1. So I'll just call that G88, and I'll call that one G89. So that one there, that one was G88, and then this one here was G99, x, y equals. So we're okay with that one. Now we have another transformation one. So clear this off. Okay. Root x so let's just go 1, 2, 3, 4. Off we go. And then open 2 is 1, 2, 3, 4. So root 0 is 0, root 1 is 1, root oh, actually maybe I should have changed the scale on the y-axis. I'll just keep it the same. All right, root 1 is 1, root 2 is 1.4, root 4 is 2, root 2 is 1.4, so that would be about there. Root 0 is 0, so sure what root 3 is off the top of my head. But well, anyways, you get a shape like this. This is y equals fx equals root x. So let's do in red. We'll call it G90, which equals root x plus 2, which equals f of x plus 2, which is the original graph, but moved 2 units to the left. So I'd have to go back 2 units. So this would be it here in red. That would be the 0. There would be 1. And then 2 would be there. So okay, that looks okay. Let's shift it back 2 units. And then G91 equals minus root x minus 1. That would be minus f of x minus 1, or minus f of x plus 1. So this is rise it up by 1 unit and then flip it upside down. So I might need a bit of construction work here. So rise it up 1 unit, so that would be there at 1. And then that 1 would be at 2. And that 4 would be up at 3. Should be there. Let's put that in dotted lines. But then you flip it. So 1, 2, 3, 4, minus 1, minus 2. Minus 3. So I'll put it in blue here. So that 1 would be at minus 1. It's a reflection through the y-axis. That 1, 2 would be at 1 minus 2. Then that 4, 3 will be at 4 minus 3. So that would be y equal to g91x. That one there is y equal to g90x. Got the answer for 91. Let's check how well it matches up. Crosses the y-axis at -1 and tapers off like that. They have more values on the x-axis, so mine is okay for the scale that I have. Okay. Yeah, okay, I think that'd be a good place to wrap it up for today. Yep. That'd be a good place to wrap it up there. Yeah. Okay. Thanks for watching.